Hello, welcome to this video on arc length, but from a function that is described parametrically. My name is Nakia Rimmer. I'm happy to help you through this journey. Here we go. What does a function parametrically described mean? It means that you have some parameter, usually it's a t, and x is a function of t and y is a function of t, and t goes between two values a and b. Well, the formula for arc length that you are introduced to when it's the standard y is f of x, there's a formula very similar to that for arc length for parametrically defined functions. They are equivalent, and so the other formula is taking y prime and squaring it and adding 1 and taking the square root. It's the same. This function is equivalent to that. So if you want to see where that comes from, I have that in the previous video. Just check my playlist on that. All right, so we take the derivative of x with respect to t, derivative of y with respect to t, square those guys, add them together, take a square root, and then we integrate between t equals a and t equals b. All right, let's work an example. We have this is a famous curve. It's called the cycloid. And what we are interested in is one arch of the cycloid. X is equal to t minus sine t. Y is equal to 1 minus cosine t. T goes between 0 and 2 pi. Okay, let's take a look at it. So we have from 0 to 2 pi. When t is 0, you'll see that x and y are both 0. You start at the origin. And when t is 2 pi, y is back to 0 again, and x is at 2 pi. So we are interested in calculating the distance traveled along the curve between these two time values, t. Here's a visual of the actual animation. Okay. And we want to know, what is the distance traveled there? We're going to work this formula. It's going to be a little bit difficult, but we can do it. Let's start with dx dt. The derivative of x with respect to t is 1 minus cosine t. Derivative of y with respect to t, well, cosine derivative is negative sine of t, so just sine t with a double negative there. Next up, square these derivatives. All right, 1 minus cosine times 1 minus cosine will give you 1 minus 2 of those cosine t's, and then plus cosine squared. And dy dt squared is just going to give you sine squared. Your job, add these together. You get that expression, which looks kind of tough. But there's a friend at the end of that expression. Cosine squared plus sine squared is your friend. Why? Because it's equal to 1. And we can take that 1 along with the other 1, put them together, and have 2 minus 2 cosine t as what goes inside of the square root. Can't forget about the square root. If we can integrate this, but we don't want to jump to integration. That's not what happens next. In the formula, we must take the square root of that. And that brings some complications, the square root of that. We'll need another identity to bail us out of that. Here we go. Let's factor out the 2. It's in common. They both have it. Let's take it out. We have to deal with this 1 minus cosine t. We need an identity to be able to rip that out and put it in and end up with something that we could actually integrate at the end. It'd be nice if that integral, what we have is what's underneath the radical is a perfect square. Okay. So we'll go with this cosine 2t is 1 minus 2 sine squared t. This is the identity where cosine of 2t has 3 different options, but this is the option we need. Okay. Well, that's about the double t. We have just a t, cosine of t. You can write this whole statement again and have a t in that spot as long as you take half on the inside of the sine. And so we have cosine t is equal to 1 minus 2 times sine squared on t over 2. All right. We have to deal with 1 minus that. And so this is why we want to use this version, because the 1 minus cancels out the 1s. And it makes the 2 positive. We are looking at, as a replacement to 1 minus cosine t, we're looking at 1 minus cosine t being ripped out and put in its place is 2 sine of t over 2, whole quantity squared. Okay? Well, that 2 and the other 2 that you factored out come together to give you a 4. Perfect square. This is a nice perfect square. You got to be careful sometimes with what's underneath the perfect square, though, if that can sometimes be negative, you want to be careful. And so actually, officially, we have an absolute value for the sine function. And for us, though, it's not going to matter. If you look at the graph of the sine of t over 2, with the absolute value bars, what that does, it takes anything that's negative and makes it positive. And so the sine of t over 2 done here on Desmos. Is that animation going to start back up? I'm sorry. There we go. In red here is the sine of t over 2. It takes those negative and pushes them up. But for what we're concerned about, for 0 to pi, it's exactly the same function. We can't tell the difference. So we can drop the absolute value bars. I say all that to say we can drop the absolute value bars. Okay. All right, great. And we can integrate this all day long. That's what's wonderful about this. So identities came in to bail us out. Okay. The antiderivative of sine is negative cosine. But whenever there's a multiplier on the variable, you have to divide by that multiplier. Like you integrate e to the kx, it's 1 over k e to the kx. If you integrate sine of kx, it's 1 over k, or negative 1 over k sine, cosine of kx. So there's a negative 1 over a half that comes into play. But that's just a 2, a negative 2. Along with the other 2, really that multiplier is a negative 4. Okay, if you want to, you can do u sub, and it'll work as well. We'll put the 2 pi in, and if we divide by 2, that's just cosine of pi. And then if we put the 0 in, it's just going to give us the cosine of 0. Pull the negative 4 out if you can. You want to do that. Pull constants out. And so, yeah, cosine of pi is negative 1. Cosine of 0 is 1. So those two on the inside there combine to give you a negative 2, along with that negative 4 that's on the outside. The arc length on our curve from 0 to 2 pi is exactly equal to 8. We did it. Okay, we had to rely on some trig identities to bail us out. Generally, this is a tough thing to do in 2D. In 3D, it's a little better because you have another term there, and it'll be easier to have something that might end up as a perfect square. But yeah, in 2D, it's kind of tough. And so that's it. Cycloid. One arch of the cycloid has a arc length of 8. Okay, thank you very much. Once again, my name is Nakia Rimmer, and I'm here to help you through this calculus journey. Please like and subscribe or comment down below if you have any questions. All right, take care. Thanks for watching.